Okay, with number 6, these ones I really need to work out. They're not in function form. So my original is x plus y squared equals negative 3. Okay. We're going to be doing the formula. So this is my original. I'm going to make x negative. I'm going to do it, and I'm going to make just the y negative. That's what this means. Make the outside the y negative. And then I'm going to compare the two. And we're going to figure out what type of symmetry this graph has. So right now I'm going to take the original function and I'm going to make the x negative only. So if I make x negative, I'll say this is 2. That will be a negative x plus y squared equals a negative 3. So I will be comparing this function and this function. That's this first case. Are these the same? No, because that's negative, that's still positive. That one's positive, that one's negative. They're not the same. So I'm going to say not even. Now, when I said you can look at the exponent and determine if it would lend itself to be even or not, that's if it's in function notation. So it needs to be like in the y equals form or the fx equals form. Okay. Because this is not in y equals form, we cannot use that same rule here. So we actually just have to solve it. And it's really nice to just plug in and solve it that way. So you just make x negative. Now I'm going to do the same thing and make y negative to figure out this one. And then I'm going to make them both negative. We'll just compare these two to each other. If I make y negative, that would give me an x, and I'm just going to make y negative plus negative y squared minus 3. So that's going to give us x negative. When you square it, it's going to become positive minus 3. So this is what happens when I make y negative. Okay. So that's this case. Now I'm comparing this guy. So these are my functions and this one. So now I'm comparing my original to my new one. And they are the same. This x, y, exactly the same. So this is x-axis. This has x-axis symmetry. And then I can compare these two. When you make x negative and y negative, compare those to each other. So this one I made x, this one I made y, compare them to each other. Are they the same? No. They have different signs on the x. So it's not odd. So it only has x-axis symmetry. All right, with this one we're going to do the same thing and figure out the type of symmetry it has. Now, since this one is in the y equals format, okay, I can just revert back to the rules we were telling you beforehand. Okay, so I don't actually have to solve it. And this one gets kind of tricky anyway when you're trying to solve it because of that absolute value. But think about the absolute value, okay? It was even. Okay, so let's go back to that graph. Absolute value is even. Okay, so this is the form. Whenever it was even, we look at this guy. Do I get moved left or right to throw off my symmetry? It's even. We don't have anything like that. nothing being added or subtracted, that is. Okay, we just have that division that's being multiplied, or that's kind of like the b value right there. It's going to just stretch it or shrink it. It's not going to really translate it to mess up the symmetry. So since we don't have that shift, then we'll still have an even graph. And that would be the best way to do that one when it's already in the y equals format. Just to look at the graph there. So this will still be even or y-axis symmetry.